look at question 2 in exercise 2G. Please pause the video if you haven't had a go. So for part A, it's very straightforward, isn't it? You've got the coordinates of P and you've got the coordinates of Q, and you just want to find the gradient of the chord joining PQ is minus 1 over PQ. So the gradient joining any 2 points, it's the change in Y over the change in X. Let me do that now. We say Q minus P. So it's going to be CP minus Q all over PQ is the difference in the Y coordinates over the change in X, which is, extend that, CQ minus P. Okay, I'm not going to break down the algebra too slowly at this stage. If you're doing FP3, you should be able to algebraically work out the difference in Y over the difference in X. I might slow this down a little bit for you. The C's cancel out. Multiplying top and bottom by minus 1. I get minus P minus Q all over PQ times P minus Q. You can see here, this cancels out that, and therefore we're left with minus 1 over PQ as required. So this is very elementary. For part B, to make it easy, let me just say Q is another point. Let's say this is the point P. Okay, so CP and C over P, and Q is CQ and C over Q. And it says here that the points P, Q, and R lie on a rectangular hyperbola, the angle QPR being a right angle. So if I say that R is about here, then the angle PQPR is a right angle. Okay. Just tidy that up. And again, we say R would have the coordinate CR and C over R. That makes sense? Now, what does that mean? If we know the gradient of the angle between QPR being the right angle, what can we say about the product of the gradient PR and PQ? Equals to minus 1. Brilliant. And we've already done the hard work in the first question. If the gradient between P and Q, gradient of PQ is equal to minus 1 over, so the gradient, let's write down gradient. Change that to MPQ equals minus 1 over PQ. What can I say about the gradient of PR? So the gradient of PR is equal to minus 1 over PR, isn't it? Just another point, same thing, but instead of Q, it's R. Okay, so the gradient between P and Q, the chord joining P and Q is given by minus 1 over PQ. Then the gradient of P and R is minus 1 over PR. Okay, so it's just the same thing that we did for PQ, but now it's PR. So it's exactly the same thing, but instead of Q, it's R. And we now know that the product of the two, because the angle, I'll stress this out, angle QPR is a right angle. So I can say that the product of the two gradients, these two, has to equal to minus 1. So let me just write that down. So it's minus 1 over PQ times minus 1 over PR has to equal to minus 1. And so if I multiply out and simplify it, I get P squared QR has to equal to minus 1. I'm just going to put a little box around that, because we'll be using that. Okay. Okay, so this is just what we're given. And now we have to show that the angle between QR and the tangent at P is also a right angle. So QR, okay, so I've drawn it in. So the angle between QR and the tangent at P is also a right angle. It doesn't quite look like a right angle here, but I have to show that. Well, what is the gradient of the chord QR? So if I use my same notation, M subscript QR, meaning the gradient of the chord QR, it's the same thing, but now that's minus 1 over QR, is it not? Is that right? Yeah, exactly the same as result we've established. Okay, so let us now multiply that with the gradient of the tangent at P. Well, how do I work out the gradient of the tangent at P? Just in case some of you are not sure, to find the gradient of the tangent to any curve, you have to find dy by dx. So in this case, if I make y the subject, then y is simply equal to c squared over x. And therefore dy by dx is equal to minus c squared over x squared. Okay. And at any point P, the x coordinate is CP. So if I sub that in, then the gradient of the tangent at P is equal to minus 1 over P squared. And just in case some of us are stuck on this, I substitute in the value of x from dy by dx with the x coordinate at P, and I will result in the gradient of the tangent at P is minus 1 over P squared. Now the next thing to do is that if I multiply the two, and it gives me minus 1, and by the 2 I mean the gradient of the chord QR with the gradient of the tangent at P, let's see what I get. I get minus 1 over QR. In fact, let me do this in blue because I don't want to confuse you guys too much. I get minus 1 over QR times minus 1 over P squared. And that equals to 1 over P squared QR. We notice something because we are given previously that P squared QR is equal to minus 1. And therefore, minus 1 over minus 1 is simply minus 1. So we've shown that the product of the gradient, the tangent at P with the gradient of the chord QR gives us minus 1. And therefore we've shown that the angle between QR and the tangent at P is also a right angle.